Hello, what we need to do now, lads, we need to look at the fifth theorem that's on the junior cert course, okay? The fifth theorem basically involves parallelograms. Now, what we need to know about a parallelogram, okay, and what we need to prove through theorem number 5 is that the opposite sides of the parallelogram are equal in measure. Similarly, the opposite angles in a parallelogram are equal in measure. So what are we given first of all? We're given the parallelogram ABCD as shown. What do we want to prove? We want to prove in the diagram, lads, that AB is equal in measure to DC, AD is equal in measure to BC, and similarly, opposite angles are equal. So DAB is equal in measure to BCD, and ADC is equal in measure to ABC. Okay? Now, the only thing I would point out there, lads, is that if we're trying to show that it's the measure of AB equals the measure of DC, then you must use the straight line to indicate that it's the measure or the how big it is, okay? But it's very important that you use the straight line there when you're talking about the measure of the side. Construction. Very basic construction, lads. You basically mark in the diagonal BD like that. Now, what is our proof? Our proof, lads, centres around basically that proving that the triangle ABD and the triangle BCD are congruent. Okay? Now we should be okay in how to do that at this stage, alright? So what is our proof? We can say straight away, lads, that the angle ABD and the angle BDC are equal because they're alternate. They're alternate because AB and DC are parallel. BD joins the two parallel lines, therefore we have two alternate angles. Now in a similar way, lads, we can say that, okay, because AD is parallel to BC, then ADB is alternate to DBC. Okay? So if those two pairs are equal, and we know that BD is common to both triangles, therefore the triangle ABD and the triangle BCD are congruent because of ASA. Angle, side, angle is equal to angle, side, angle. Now, what does it mean if they're congruent? What it means, lads, is that if two triangles are congruent, the measure of corresponding sides and angles are equal. Okay? And because of that, we have that DAB is corresponding to BCD because they're both opposite the same equal angle. Therefore, DC is equal to AB. They're corresponding because they're opposite the same equal angle. And finally, AD is equal or corresponding to BC because they're opposite the same equal angle. So therefore, lads, opposite angles are equal and opposite sides are equal in a parallelogram. Any questions, please? Okay, thank you.